This lesson is going to be on logs. Logs are the inverse of an exponent. Logs is short for logarithm. Your calculator has a key that says log, and we're going to talk about that a little bit. But let's talk about inverses first. Inverse. You already know inverse functions a lot. So for example, plus, the inverse of a plus is a minus. Addition, subtraction. Multiplication, division. The square and the square root. Those are all inverses. One does them, one undoes them. If I have something like this, 10 to the x, the log undoes that, okay? So this is what we're going to focus on, is how to solve equations where our unknown is up in the exponent up here. And we're going to need to use logs. Logs are really powerful, really convenient, and it's a type of math that we haven't done before. Pretty much everything else up until logs has been this sort of stuff, kind of arithmetic. Logs have their own rules. Now we can, if you want, we can derive the rules from arithmetic and exponents and stuff. And we will a little bit, but I will also just be presenting rules. So let's try this. Log base 6 of 36 equals 2. And it goes like this. The base to the exponent equals the argument. So that's going to be 6 squared equals 36. And the 6's are called the base. Okay, it's the base of your exponent, or the base of the log. And this guy over here, this is our exponent. Okay? And then that's the argument, 36. Okay? We can write this in a formal way if you would like. We could say log base b to the, let's see, what do x, let's do the y. Log base b to the y equals x. Remember that. Or b to the x equals y. These are equivalent expressions. Good thing for the notebook. Going back and forth between them is going to be critical. You need to be able to fluidly move back and forth between this. You'll notice I draw this little arrow, this little swoop. Base to the exponent equals the argument. That little loop like that helps me do these problems. I keep that pattern in mind. When they are drawn the other way, I usually will redraw. When the expression's drawn the other way, I'll redraw them this way. So let's try some of these. So how about log base 12 of 1 over 144, and I think that's going to be negative 2. Let's check that out. So 12 to negative 2 equals 1 over 144. Is that correct? Let's take a look. So the negative exponent means it's going to be like this, 1 over 12 squared. doing well. Now let's try to go the other way around. So how about this one instead? 1 over 5 to the x equals y. I want to write this in the log way. So base, argument, exponent. Log to the 1, base 1/5 of y equals x. Okay, and we can check our work. 1/5 x equals y. 1/5 x equals y. Okay, we're doing well. Okay, so that was the basics. Let's try to solve some problems with these, or do a little more. So how about this? 4 to the 3x minus 9 equals y. Let's rewrite that in its other form. So there's my base, exponent, argument. So log base 4 of y equals 3x minus 9. We just shifted them back and forth. Check your work. 4 to the 3x minus 9 equals y. Okay, we're good. Okay. How about this one instead? Log base 4 of 16 minus 2x equals y. Okay. Or to the y equals 16 minus 2x. Okay. Doing well. Now, how do we actually solve these? Let's try another problem here. Okay. How about log to the x equals 42. Okay, 10 to the x equals 42. How do I solve for that x? Well, I want to rewrite it in log form. So in this case it's log base 10 of 42 equals x. Grab your calculator and try this. Now the calculator has a key, says log. It might say log base 10 or just log. And do that. Do log 42 equals, and you'll get something like x equals 1.623, and it just keeps going on and on and on. Okay? So what that says, and you can check your work, what that says is 10 to the 1.623, it's an irrational number, it goes on forever, equals 42. And you can check it with your calculator by doing this key, 10 with that caret, and then 1.623. Some calculators have x to the y, things like that, where you have to work through how your calculator works, notice how these other keys work. But if the base is 10, we're doing well. We can do this with our calculator, no problem. However, with other bases, it gets a little challenging. So let's take a look at that. So how about this one? 1.04 to the x equals 2. Huh. Now, our calculator does not have a base 1.04 on it, so we need a way to solve this problem. And so one of the techniques we use is going to call the power rule. So I'm going to start off by logging both sides. So log of 1.04 to the x equals log of 2. Now here is where the power rule comes in. It's actually really super powerful. This x, whatever is in the exponent, comes here and drops in the front like that. So now we have x log 1.04 equals log base 2. So before I go too far, keep in mind that that is just a number. It's a number on your calculator. Log, now I didn't write the base, but it's log base 10. Okay? This is just a number, that's just a number. We know how to use numbers. So, log, divide this out. Log 1.04, and you get x equals log 2 over log 1.04. Punch that into your calculator, you get an answer. Okay? I don't have a calculator in front of me. My phone is my calculator, and I'm recording this video with my phone. So you'll have to trust me, that's how it works. Okay, the power law, or the power rule, says if there's a power right here, you bring it down. Which we can write this out as this. So, log of m to the n equals n log m. So I skipped the bases. Doesn't matter what base you use. You can put a base in here if you'd like. B. But I want you to notice that this exponent drops in front. Once it drops in front, we can then divide it out and do what we need to. This is the power rule. Okay. Okay. Let's try another one. Let's try another example here. How about 6 to the 2x equals 14? Okay. Log both sides. That. Now, do the power rule. This guy comes in front. So I will have 2x log 6 equals log 14. Shh. Tell my chalk to be quiet. Now I just need to solve for x. I'm going to move this up to here. So we have 2x log 6 equals log 14. 2x log 6 is log 14. I'm going to divide by log 6. Those simplify to 1. 2x equals log 14 over log 6. I need to get this 2 out of here. Divide by 2. Like that. And I have x equals this. What's with this chalk? So, x equals log 14 over log 6 divided by 2. A little ugly, but your calculator can handle it fairly easily, not a big deal. Okay. Let's try another one. How about this? Log base 5 of 200. What's that equal? Again, your calculator does not have a log base 5 key. We need to be creative and figure out how to do this. So, question marks aren't really good math terms, so let's throw an X here instead. And I recognize this format. Red chalk. 5 to the x is 200, right? So 5 to the x is 200. And I need to get this x out of here. Let's go ahead and log both sides. So I'm going to say log 5 to the x is log 200. This is squeaky chalk today. Power rule, this guy goes in front. X log of 5 equals log 200. Hey, look at that. We solved for x. How did we do that? We put it back into exponential form, used the power rule to pull this x out front, so x log 5 to log 200, divided by log 5. That simplifies to 1. X equals log 200 over log 5. I want you to look at this. Here's what we started with. We started with log base 5 of 200. Compare these for a minute. And I said this equals x. How do these two compare? Do you see a pattern? This one, these are log base 10. If I don't specify a base, either the base doesn't really matter, or we just call it base 10. In this case, we'll just call it base 10. Okay, we can do 10 throughout. What I have done, this is called the change of base formula. Change of base. I remember it this way. It's the log of the argument divided by the log of the base. Okay? There's probably some sort of equation. Let's see. Log base b to the m is log m over log b. So that's the change of base formula. Okay. So let's do one last example. Let's do it right here. I have log base 3 of 17. That's going to equal log of 17 over log of 3. And again, you
can use your calculator to get that exact, or to get that answer.